Section 7.1 is on the inverse sine, cosine, and tangent function. So we're going to go ahead and start with y equals sine of x. In order to have an inverse, first of all, my original function has to be 1 to 1. If it is not 1 to 1, we either have to restrict it, or if we don't restrict it, we can't have that inverse. So if we take a look at the sine function, this function oscillates between negative 1 to 1. If I draw a horizontal line, in order to check to see if it's 1 to 1, it fails a horizontal line test. So it crosses here, 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 and here, for example. So that means that this function without restrictions is not 1 to 1. But I'm going to try to look for an inverse sine. So what that means is that I'm going to need to restrict the sine function. So if I go and I restrict it between negative pi over 2 to pi over 2, then this piece right here is going to be 1 to 1. This piece does pass a horizontal line test. So that means that I can restrict y equals sine of x to be between negative pi over 2 to pi over 2, and it would be 1 to 1. Another restriction that we could use if we wanted to would be pi over 2 to 3 pi over 2. So this piece between pi over 2 and 3 pi over 2 would also be 1 to 1. So it really doesn't matter which one you ended up using, but we're going to use negative pi over 2 to pi over 2. And to be consistent, this is what we're going to use for the rest of the class. So again, we're going to go ahead and we're going to restrict the function between negative pi over 2 to pi over 2. Now the range is still the same as it was before, so it's between negative 1 to 1. That doesn't change. So let's go ahead and trace our original sine function on here. So the original sine function would be this one. And in order to find the inverse function graphically, what I would do is I would take whatever's above the y equals x, copy it to the bottom. Whatever's below the y equals x, you copy it to the top. So this is a reflection. The inverse function is a reflection of the original function. So let's go ahead and trace out the inverse function. If you have a hard time with reflecting over the line y equals x, then go ahead and switch the points. So whatever is an x or whatever was an x before is going to change to a y. Whatever was a y before is going to change to an x. So this point is negative pi over 2, negative 1. So that means that for the inverse sine, it's going to become the y is going to become a negative 1, and the x is going to become a negative pi over 2. So this x became the y, and the y became an x value. Same thing happens with this x and this y value. This is pi over 2, 1. So then it becomes 1 pi over 2. And then for the point 0, 0, if I switch those points, it's still going to be 0, 0. So we're going to go ahead and graph it through negative 1, negative pi over 2, 0, 0, and 1 pi over 2. So y equals sine inverse of x is the inverse of the sine function. So this is the notation that we use. This means that x is equal to sine of y. So x is equal to the sine of this value here. So whenever we have let's take a look at this part right here. Let's ignore these for a second. Whenever we have x equals sine of y, this input on the sine is always the angle. So we know that the angle for sine has to be between negative pi over 2 to pi over 2. That means that this y has to be between negative pi over 2 to pi over 2. So this x is a value for sine. So it's basically, if I wanted to find the value or the restriction for this right here, it would be what sine oscillates between. So sine oscillates between negative 1 all the way to 1. So using this function, this x is what the sine function oscillates between, and this y, what the sine inverse is equal to, is the angle for the original sine function. We can also take the f inverse of f of x. So remember that f inverse of f of x is equal to x for all of the x's within the domain of the input function, f of x. So that means that if we're using the sine inverse of sine of x, this is equal to x for all of the x's within the domain of the sine of x. And remember that we gave a restriction on the sine of x, and we said we're going to restrict the x for this sine between negative pi over 2 to pi over 2. So the input for this sine is always an angle, and we restricted the angle between negative pi over 2 to pi over 2. Now if I do the opposite, if I take the f of the f inverse of x, then that means that this is equal to x, this whole thing is equal to x, only for those values of x within the restriction of the input, which in this case is an inverse function. So then sine of sine inverse of x is equal to x for the x's within the restriction of this input. So this input in the sine inverse is what the sine oscillates between. Sine oscillates between negative 1 to 1. So this input for sine inverse is not an angle. This input for sine is an angle. Input for sine inverse is what the original function oscillates between. So let's go ahead and do some examples on this. So the first example is to find the exact value for y is equal to sine inverse of radical 3 over 2. So let's go ahead and check our restrictions. Before we start solving anything, we need to make sure we always check our restrictions. So if this input, radical 3 over 2, is the input for sine inverse, remember, inputs for sine inverse are what the original function oscillates between. The original function oscillates between negative 1 to 1. So if radical 3 over 2, which is the input of the sine inverse, is within this restriction, then we're okay. Then we're going to be able to find an answer. If this input for the sine inverse is not within this restriction, negative 1 to 1, then that means I cannot simplify this. This would be undefined. So let me translate in case this still didn't make sense. So what this means is that sine of y is equal to radical 3 over 2. So you take the sine of this y, and that's equal to the sine of the sine inverse of radical 3 over 2, and this sine of sine inverse is equal to the input as long as that input is within the restriction of the sine inverse, which again is negative 1 to 1, and it is. That means I can go and rewrite this equation or function as sine of y is equal to radical 3 over 2. Now we're going to try to solve for y, and now y is the input for sine. So if it's the input for sine, then that means it's an angle. So we're going to basically look for what angle gives me back a sine value of radical 3 over 2. Remember, we had a restriction on the sine function. The sine function was restricted on negative pi over 2 to pi over 2. So that means that we're looking at the right side of this unit circle. We're not going to use anything on the left side because this is between negative pi over 2 to pi over 2. We need to make sure we use the restrictions. So the angle that gives me a sine of radical 3 over 2 is going to be this angle formed by the x-axis and this line, which gives me a pi over 3. So this pi over 3 has a point of 1/2 radical 3 over 2. So the sine of the angle is equal to radical 3 over 2. So in order to answer this, I need to find the y value. The y value is equal to the angle, so y is equal to pi over 3. So let's go ahead and do another example. Well, let's go ahead and find y equals sine inverse of negative 1/2. Just like we did on this one, we need to check this restriction. So we need to check to see if this input is okay. So is negative 1/2 within the input for the sine inverse function? Remember, the input for sine inverse is what the sine oscillates between. So the sine goes between negative 1 all the way to 1. So then this is in between negative 1 to 1, which means I can go find the answer for this. I can go ahead and find y. So then let's go ahead and rewrite this. So this means sine of y is equal to negative 1/2. So now we're going to find the angle. So remember, the input for sine is always an angle. We're going to find the angle, that's for sine, the angle that's going to give me a sine of -1/2. So let's go ahead and draw the unit circle. And we're still using the same restriction for the angle. The angle is going to be between -π/2 all the way to π/2. So a sign of negative is going to be on the bottom. So let's go ahead and draw the angle corresponding to that. So that's going to be -π/6. And for this one, the point is radical 3/2, -1/2. That means that the sine of this angle is equal to -1/2. So that means that for this one, y is equal to the angle of -π/6. So we want to make sure that we give our answer for the angle based on this restriction, -π/2 to π/2. Let's go ahead and try another example. So the next one is y equals sine inverse of 3. So we want to check our restriction. That's always going to be the first step, checking our restriction. So let's go ahead and check to see if 3 is within the restriction of the inputs for sine inverse. Input for sine inverse is what sine oscillates between. It oscillates between -1 to 1. 3 is not between -1 to 1, which means that we are not able to find an answer for this because this is undefined. And again, it's because this input for the sine inverse does not meet the restrictions for what sine function oscillates between. Let's go ahead and use the second rule that I showed you guys. So now we're going to go ahead and utilize these rules. We're going to find the sine inverse of sine, and we're going to find sine of sine inverse of x. So let's go up for a specific angle in this case. So let's go ahead and try to find the exact values for sine inverse of sine of -π/8. So in order to answer this, what I need to do first is I need to make sure that this input is okay. So if it meets the conditions for the restrictions of this sine function. So what kind of inputs can we have in the sine function? Remember, this is equal to the input only if this input is within the restrictions of the inner function. So we're going to check to see if -π/8 is within the restrictions of the inputs of sine. So the input of sine is an angle. We restricted the angle between -π/2 to π/2. So we're checking to see if -π/8 is between -π/2 to π/2. And because -π/8 is within this restriction, we're able to find an answer for this. So remember, sine inverse of sine is of some angle is equal to that angle as long as that angle is within the restrictions. Because it is, that means we can simplify this to -π/8. Let's go ahead and do another example. So for the next one, we have y, or just sine inverse of sine of 5π/8. So we're going to do the same thing. We're going to check to see if this input is within the restriction for the inputs for sine. So it's always checking the input against the restrictions for the inner function. So is 5π/8 within the restriction of -π/2 and π/2? And if you have a hard time comparing these, what I would suggest is make them the same denominator. So I would change this to 4π/8 and so -4π/8 and 4π/8, because this is bigger than 4π/8. It does not meet that condition. That means I need to go and find an equivalent angle that's going to give me the same sine value. So let's go ahead and find an equivalent angle that's within the restriction. So first, I'm going to go ahead and find, on the unit circle, I'm going to find 5π/8. What 5π/8 does is it breaks up the unit circle, or the top half of the unit circle, into 8 pieces. So let's go ahead and break it up into 8 pieces. This is going to give me 2 pieces. Then this gives me 4 pieces if I break each of them in half. And if I break each of these in half, it's going to give me 4 pieces here, and it's going to give me 4 pieces here. So let's go ahead and find 5 pi over 8. This is pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8. So it's right here. But again, my restriction for this sine function is, sorry, for the input for the sine function is between negative pi over 2 to this pi over 2. So we have to be on this side of the unit circle, not on the left side. So now what I need to do is I need to find an equivalent angle on the right side that's going to give me the same sine value. Remember, sine is always the y value, whatever that y value is. We don't know what it is because it's not on the unit circle. But if I go directly across, this point right here is also going to give me the same exact y value. So that means that this point is now going to be my reference point. So what is this angle right here? So this is pi over 8, 2 pi over 8, 3 pi over 8. So that means that sine of 5 pi over 8 is the same thing as sine of 3 pi over 8. So I'm going to go and replace this 5 pi over 8 with a 3 pi over 8. So this becomes sine inverse of sine of 3 pi over 8. And now I'm going to go ahead and check the restriction, 3 pi over 8 against the restriction, or the input for sine, which is 3 pi over 8 against the restriction for the sine. So my input is now 3 pi over 8, and I'm checking to see if this is in between negative pi over 2 to pi over 2, and it is, and it should, because that's exactly what we tried doing here, is we looked for an equivalent angle within that restriction. So because 3 pi over 8 is between negative pi over 2 and pi over 2, that means that this simplifies to just the input, which is 3 pi over 8. So that means that sine inverse of sine of 5 pi over 8 is actually equal to 3 pi over 8. Let's go ahead and do one more example. So this is sine of sine inverse of 1.5. So if we have an angle, then we can change the angles. So if we have an angle as the input, we can actually find an equivalent angle that's going to give me the same sine value or cosine value or tangent value, whatever it is you're looking for. But if I have an input that's not an angle, then we can't always go and change it. So let's go ahead and check this one. So for 1.5, 1.5 is an input for the sine inverse function. Inputs for sine inverse functions are not angles. So inputs for the sine inverse functions have the restriction of what the original function sine oscillates between. So sine oscillates between negative 1 to 1, so I want to check to see if this input is within negative 1 to 1. So is 1.5 between negative 1 to 1? Because it's not, then that means this portion is undefined, just like we did before. So that means that, so just like on this example, this 3 was not within negative 1 to 1. So that means that this one is also undefined, which means that the sine of the sine inverse of 1.5 is undefined as well. Alright, so let me go ahead and go back to the worksheet and make a comparison between all of my restrictions that I was checking and the function that I was given. So for sine inverse, for the first one, sine inverse of radical 3 over 2, I was checking to see if radical 3 over 2 was between negative 1 to 1. So why was I checking that? That's because my input is within the sine inverse function. So if I check the input within the sine inverse function, we know it's between negative 1 to 1. So that's why here we're checking it against negative 1 to 1. This is a sine inverse function also, so this is an input for a sine inverse function. We just said that the input for the sine inverse function is x, so x is between negative 1 to 1. So then this negative 1/2 has to be between negative 1 to 1. Same thing with this one. This is a sine inverse function, so we want to check to see if this input is within the restrictions for the sine inverse function. The input has to be between negative 1 to 1. Because it's not, we make it, or we say that it's undefined. Now for these, remember that whenever you take the f inverse of f of x, it's equal to x only for those x's that are within the restriction of the inner function. So if I take sine inverse of sine of some angle, this angle has to be within the restriction of the sine function. So this input has to be within the restriction of the sine function. So the restriction of the sine function, so this matches this first row here, is negative pi over 2 to pi over 2. So I'm checking to see if negative pi over 8 is between negative pi over 2 to pi over 2. For this one, my input is 5 pi over 8. It's the input for a sine function, so it still matches that first rule. My input was x, in this case 5 pi over 8, and x has to be between negative pi over 2 to pi over 2. So we're checking to see if 5 pi over 8 is between negative pi over 2 to pi over 2. For the last one, we're checking, or we're finding the sine of the sine inverse function. So sine of sine inverse, that's this one. So then the input for the sine inverse has to be between negative 1 to 1. Again, that's because that's what the sine function oscillates between. So 1.5 is not between negative 1 to 1, so that means that this is undefined. And just to recap, if I have an angle that's not within the restriction, I can change it. But if I have a value that's not within the restriction, and this value is the input for the sine inverse, I cannot change it, so then it would be undefined.